Alright, I'm going to go over this review with you guys. I'll work out every problem here. You also have solutions posted. In class, I had outlines, kind of the steps that you should be kind of going through in your head as you're solving any sort of triangle. Alright, so when you're solving triangles, you want to first ask yourself, is it a right triangle? And if it is a right triangle, you can use SOHCAHTOA or Pythagorean theorem to get all the information that you need. If it is a non-right triangle, so for non-right triangles, there's two cases. All right, so you are either going to have one side and two angles, or you have two sides and one angle, right, where you have one pair. When I say pair, I mean, for example, you have angle A and side A, right? So if I have an angle A and a side A, or an angle B and a side B, as long as you have something that matches, right? This is the biggest thing, right? Regardless of if it's one side and two angles or two sides and one angle, you should have something that matches, all right? And when this happens, you can use law of sines, all right? The other non-right triangle cases that you're going to see are if you have a side angle side, so you have two sides and one angle, but you have no pairs, you have no matching pair, meaning that that the angle that we give you isn't corresponding to either side that we give you, right? And in this case, you can't really find any other angle easily, so you can't really come up with any pairs in that case. So what you would do instead is you would use law of cosines, right? And then the other case is if you have three sides, right? So if you have no matching pairs, no matching pairs, or you have three sides, you would use law of cosines. All right, and I'll show you what that means here. So if I look at this problem here, let's take a look at the information that we have. Keep in mind the sides that we are given correspond to the angle that they're facing opposite of. So this 20 meters is going to be side C. This 18 meters is going to be side B. And I have right here an angle A. So I have two sides and one angle. Does the one angle match any of the two sides? Right? It does not, right? I have an angle A, I don't have a side A. If this is the case, we had just said that we would use law of cosines. Now we give you all the formulas on the test, so you don't have to worry about memorizing, like triangle. You would use the version of law of cosines that relates right triangle A with sides B and C. And if you check the law of cosines, that's going to allow us to find, side A. So I can do A squared equals B squared plus C squared minus 2BC cosine of A. All right, plug in all the information that we have. So I'm going to have a B squared, so 18 squared plus 20 squared minus 2 times 18 times 20 times cosine of 104. All right, all you have to do is plug this in your calculator, see what you get. All right, should get you 898.1838, something like that. And then you can square root both sides, and then you get A should be to the nearest tenth. It'll round up, so it'll round to 30 meters. All right. Now that we have a side A, we can find our other two angles. Because keep in mind, now that I have a side A and I was given an angle A, right, that's a matching pair. I can use law of sines now, right? And if I want to use law of sines, I can use that to find either angle B or angle C. It doesn't really matter. Let's say I want to find angle B. remember that the law of sines is sine b over b, which is sine b over 18, equals sine a over a. So sine of 104 over 30. All right, so then to get sine b by itself, I would multiply 18 on both sides, cancel it out. And then I get sine b is 18 times sine of 104 over 30. All right, and then I would do sine inverse on both sides to cancel it out. All right, and then I would plug this whole thing into my calculator. All right, this whole thing. Sine inverse of 18 times sine 104 over 30. And that should get you that angle B is 35.6 degrees, right? Okay. So now that I have another angle, right? I have an angle. I was given an angle. So what we can do is we can now just subtract our two angles from 180, right? So to find angle C, I would just do 180 minus 104 minus 35.6. Right, so 180, right, type that in my calculator. Should get you, for angle C, 40.4 degrees. And then that solves the triangle. Right, we have all of our sides, all of our angles. Right, so a lot of written work there, but really not a lot of things that you needed to recall from memory. Right, you had the formulas. You will be given the formulas on the test. The biggest thing that you should know is know what to do or what formula to use in each case. Right, so if you look at this one right here, notice that I have a side, and a side. Right, I have three sides, so I would again use law of cosines. Right, law of cosines has a formula where you can relate all three sides to each other to find an angle. And now if you remember from our law of cosines lesson, you always want to find the biggest angle first, right? And the biggest angle is going to correspond to the biggest side. Here, B is our biggest side, so I would use the version of law of cosines that gets us cosine of B by itself on one side. So I'm going to get cosine of B equals A squared plus C squared minus B squared over 2AC. So this is going to get me cosine of B, which is 21 squared plus 13 squared minus 29 squared over 2 times 21 times 13. All right, and then I would simplify the top and then simplify the bottom because that's a lot easier to put into your calculator. And so I get cosine of B is negative 231 over 546. And then to get B by itself, I would do cosine inverse of both sides. And then we can plug this into our calculator to get angle B. So I should get that angle B is 115 point, well, to the nearest tenth, it'll just be 115 degrees. We always want to use the biggest angle first, right? I saw some people in class use another angle or try to find another angle first and then got a completely different answer, right? Just because the way that your trig functions work, there are multiple values for which that satisfy that particular trig value, right? So you want to be sure to use the biggest one because your calculator is only going to spit out values within a certain interval, right? And then there's other values that are also valid solutions that you're not going to get from using the smallest value, right? So you want to make sure you get the biggest angle first because that's for sure going to be in the correct quadrant, I guess, when you're plugging it into your calculator. All right. Now that I have an angle B, I can find another angle, right? So if I have angle B and I have side B, right, that's a pair. I can use the law of sines. So let's say I want to try to find angle A. I would do sine A over A, which is sine A over 21, equals sine B over B, which is sine of 115 over 29. And then I would multiply 21 on both sides. I get sine of A is 21 times sine of 115 over 29. And then I can do sine inverse of both sides. And then this is what I would plug into my calculator to get my answer for A. So we should get to the nearest 10th, 41 degrees. All right, so that's for our angle A. So now that I have two angles, all I have to do to find angle C, add them, subtract from 180. So I could do 180 minus 115 minus 41. So I get angle C is 24 degrees. All right, let's keep going. Over here for area problems, you can kind of follow a similar method of just trying to decide which formula to use. So with area problems, if you're given a side angle side, right? So similar to our law of cosines case, where we have no matching pairs, but we have two sides, then we can use the 1/2 BC sine A, that formula. Or we can use, if we have three sides, we can use Heron's formula. All right, so let's see what we have in this problem right here. In this problem, we have three sides. If we have three sides, we're going to use Heron's formula, right? Recall that Heron's formula is my area is S times S minus A times S minus B times S minus C, all under the square root, right? Where S is the semi-perimeter, A plus B plus C over 2, right? So I'm going to find S, which is going to be 9 plus 12 plus 15 over 2, which is 36 over 2, which is 18. All right. Now that we have our semi-perimeter, we can just go ahead and plug this into our formula to find the area. So my area is going to be the square root of 18 times 18 minus 9, 18 minus 12, and 18 minus 15. Right, you'll notice that my A, B, and C are not in order. It doesn't matter how you do it, you're going to get the same answer. All right, multiplication is commutative. It doesn't really matter what order you do it in. If you want to simplify this a little more, you get 18 times 9 times 6 times 3. All right, and then that gets you 2916. So my area is going to be, once you put this in your calculator, is going to be 54, which is the unit square inches. All right, so not a hard formula to use. All right, now if you look at the next one, it's another area problem, right? We're trying to find the area. Keep in mind now that I have a side angle and a side. If I have a side angle side, I would use BC sine A, right? This 5 is going to be B, this 8.4 is going to be C, and this 45 is A. All right, so my area is going to be 1/2 times 5 times 8.4 times sine of 45. All right, so my area is going to be to the nearest 10th, 14.8 square miles. Once again, pretty easy formula to use, right? The area problems are some of the easier problems that you're going to see on the test. All right, let's continue with more triangles. In this problem, it looks similar to the others. In this case, I only want to find angle B, right? So on the test, we might give you some problems that you don't have to find everything. We're not going to ask you to solve the triangle, but we'll ask you to find some measurement, right? Whether it's a side or an angle. Here I want to find the measure of angle B. Let's look at the information that I have. I have C, angle C, which is 87 degrees. I have little c, which is 9 yards, right? That's the side that's across my 87. And then this 7 is going to be my side B, right? It's right across my angle B, right? And my angle B is what we're looking for, right? So notice that you have a side C and an angle C. All right, so I'm going to use law of sines, right? If you have a matching pair, I'm going to use law of sines to find our missing angle. So I want to find sine of B, so I'm going to put that on top. Over B, which is 7, equals C or I'm sorry, sine c over c, which is going to be sine of 87 over 9. Now to get b by itself, I would multiply 7 on both sides, cancel it out. We get sine of b is 7 times sine of 87 over 9. And to get b by itself, we would do sine inverse on both sides. All right, and then once you plug this in your calculator, you should get that angle B to the nearest tenth. It's going to round up, so it's going to be 51 degrees. And that's all you have to do for this one. We don't have to do anything else because the directions just say find angle B. I don't have to solve the triangle. All right, so we're good with that problem. All right, now this one, I want to find side B. All right, now this one, take a look at what we have. We have an angle A and a side A. Right, that's a pair that matches, so I can use law of sines. I'm given an angle B, so I can easily find my side B. Right, so I would use the version of law of sines that has the side B on top. So I get B over sine B, which is B over sine of 93, equals A over sine A, which is 28 over sine of 58. All right, and now I want to get sine of 93 to the other side. Cancel it out, so I get B is 28 times sine of 93 over sine of 58. Plug this directly in your calculator, and that'll get you your answer for B. So we get B is 32.97, which again is going to round up to 33 yards. And the directions just say to find B, right? I don't need to solve the triangle, so I can stop there. All right. Now with trig functions, you want to keep in mind, this is the one thing that we're not going to give you guys, is the x, y, and r form for sine, cosine, and tangent. All right, so I want to find sine. Remember that sine is y over r, and I'm given cotangent. If you don't remember cotangent, you should at least know that it's the reciprocal of tangent. And tangent, you should know that that's y over x. That would make cotangent x over y, right? Just take the reciprocal. So that means this this 8 is x, and this y is 15. So I already have sine of theta is 15 over something, right? I don't know what r is. But to find r, we can put this in a coordinate plane. I know that x is positive, and y is also positive. All right, so it's going to get you a point right here. You can draw a right triangle out of it, and then to figure out what this r value is going to be, we can use Pythagorean theorem. All right, x squared plus y squared equals r squared. All right, which is going to get us 8 squared plus 15 squared is r squared, which is 64 plus 225, which is 289. And then we can square root both sides, and we should get r is 17. All right, so that would make sine y over r, which is 15 over 17. And that's all I have to do there. I don't need to find all 6 trig values in this one. I can just leave it alone. All right, now if you look at the next one, I'm given cosecant, and I want to find tangent. Remember, cosecant is the reciprocal of sine. If sine is y over r, that would make cosecant r over y. So that would make this square root of 17r, and this 4 down here y. All right, so I can go ahead and draw that. I wasn't given any restrictions. I should have said what quadrant that this is going to be in. Let's just say it's in the first quadrant, right? So I can say r, I know, is the square root of 17. Y is 4. I don't know what x is. To figure out what x is, we can use Pythagorean theorem. X squared plus y squared equals r squared. So I get x squared plus 4 squared equals the square root of 17 squared. So then I get x squared plus 16 equals 17. Subtract 16 on both sides. I get x squared equals 1, and that would make x 1. All right, once again, I wasn't given any restrictions, so it could be in the first or second quadrant. So I'm just going to say it's in quadrant 1. All right, let's just say quadrant 1. Then I know that tangent, since tangent is y over x, it's going to be 4 over 1, which is 4. All right. That's as hard as these kinds of problems get. is if you have a radical, right? But sometimes you don't even have to do anything with the radical, right? I know you guys see it and might panic and not know what to do, right? But it's the same exact process every time. All right. Here, let's read the directions. I have that angle C is a right angle, and I want to solve the triangle. All right, so I'm given angle A is 30, A is 7, so I know that angle C has got to be 90, right? We were given that in the directions. We can choose to draw it if we would like. That might make it a little bit easier. So I can say this is angle C, this is A, which is 30. I have side A, which is 7. And then from here, I can say that angle B has got to be 60. Right, because the two acute angles in a right triangle have to be supplementary, right? So that already gets us one of our angles, right? I get the measure of angle B is 60. All right. Now to figure out my sides, I can use SOHCAHTOA. You could use the fact that this is a special right triangle. We didn't ask you to know that for your test, but I mean, if it shows up, you should take advantage of it. So then you can say that since this side across the 30 right here is 7, you can say that the side across the 60 is 7 square root of 3. All right. Maybe you didn't want to do that. Maybe you didn't recognize that. Then you could say that whatever B is dependent on SOHCAHTOA, right? I can use a tangent of 60 is B over 7, right? So opposite over adjacent. And then all you have to do is multiply by 7 on both sides to cancel that out over here. And then I get 7 times tangent of 60 is my side B, right? Either way, I might want to have some rounded answer, right? So then if I do 7 times tangent of 60 in my calculator, I'll round to, it says the nearest tenth, so I can say that this is about 12.1. All right, so then I get that for side B. All right. Now to find my missing side, I can do one of two things. I could use another trig ratio, or I can use Pythagorean theorem now that I have A and B. A and B, right? So I'm going to try Pythagorean theorem, right? Maybe some of you are more familiar with that. So I want to use A squared plus B squared equals C squared, which is going to get me 7 squared plus 12.1 squared. So that's going to get me 49. Let's see what 12.1 squared is. It is going to get us 146.41. All right, so when you add those together, you should get 195.41. And then you get C is, right, this is going to round up to 14. Right, which is the same thing that we would have gotten if we had just taken advantage of the fact that it's a special right triangle. But if you didn't recognize it, you would have done the way that I wrote right now. But if it shows up, that's acceptable to do. All right. Now with this one, let's see what we have. I have the measure of angle B. I have side C. I also know that angle C is a 90-degree angle, right? It's a right angle. Same as before, I can draw this just to get a better idea of what's going on here. I can say that this is C, this is B, this is A. I have that B is 48 degrees, C is 7.7. My angle C is 90. From here, I can figure out that angle A has to be 42 degrees, right? They have to add up to 90, the A and the B. All right. Now I can use SOHCAHTOA to figure out what one of my other sides is going to be. Let's say I want to do sine of 42. Right. It doesn't matter what you do. If you had picked another angle, then you would have gotten, you might have found, I don't know, a different side than I'm about to find, but you should still end up with the same answer in the very end. So I get sine of 42. Sine, remember SOHCAHTOA is going to be opposite over hypotenuse, so it's going to be side A over my hypotenuse, which is 7.7. So I can multiply 7.7 on both sides, and then I get this as my answer for A. All right, now if I plug that into my calculator, we should get 5 10.15, so to the nearest 10, 5.2. All right, that's one of my answers for one of my sides. All right, I can do Pythagorean theorem to try to find side B, right? But let's say I want to use another trig ratio, right? So why don't we try cosine of the same angle? Let's do cosine of 42, right? Because if I use 42, notice that B is my adjacent side. So cosine of 42 is adjacent over hypotenuse, which is B over 7.7. Again, multiply 7.7 on both sides. So then we should get for B 7.7 times cosine of 42, which is going to be 5.7. And that solves the triangle, right? We have all of our sides, all of our angles, so we're good. That's all we have to do in this problem. All right? And again, think about the very first few minutes of this review, right? So when you're solving triangles, consider the information that you have and decide what to do from there. Because this one was a right triangle, I was allowed to use SOHCAHTOA and I was allowed to use Pythagorean theorem. Right, but if this wasn't a right triangle, I wouldn't have been able to do that. I would have had to look closer at the information that we have had to use law of cosines or law of sines. All right, let's keep going. Last page of this review. So we're probably going to give you another question where you have to find all 6 trig values given a point in the coordinate plane. This particular review only asks for one particular value, but I'm just going to show you how it would, or what it would be like to find all 6 trig values. Right, so if I'm given this point 12, negative 16, keep in mind this 12 is x, this y is negative 16. All right, so that means my r value is going to be whatever I get when I do x squared plus y squared equals r squared. All right, so it's going to be 12 squared plus negative 16 squared, which is going to get me 144, plus 256, which is 400. And then when you go to square root both sides, I get that my r value is 20, right? My r value is always going to be positive. So now I have x, y, and r. I can do, well, I can find what we were asked, right? I could find cosine of theta, right? But I'm going to find all 6 of them, right? That might be more helpful for you guys. So sine of theta is going to be y over r, which is going to be negative 16 over 20, which simplified is going to be negative 4 over 5. All right. Once you have sine, you can immediately find cosecant, right? Remember that those are reciprocals of each other, so cosecant is going to be negative 5 over 4. Just flip your fraction. All right. I can find cosine, which is what the original problem asked, right? It's going to be x over r, which is going to be 12 over 20, which is 3/5. All right, keep in mind that secant is the reciprocal of cosine, so secant has to be 5 over 3. All right, now I want to find tangent, which is going to be y over x, which is going to be negative 16 over 12, which is negative 4 over 3. All right, so then we get cotangent is negative 3 over 4. All right, just take the reciprocal. All right, and that's all 6 trig values. Not super difficult. A little bit time consuming, but shouldn't be super difficult. If we give you just the ordered pair and not the graph, right, same idea. What we can do is we can draw it and decide where it is from there. I know that x has to be 2, y has to be 5. So I know, let's say this distance is 2. This vertical distance is the square root of 5. And then to find r, I would do Pythagorean theorem. So I would do x squared plus y squared equals r squared. So 2 squared plus the square root of 5 squared equals r squared. So I get 4 plus 5 is 9. So then r is going to be 3, right, if I take the square root of 9. Right, and then from here I can find all 6 trig values. I can find sine, which is y over r, so that's going to be the square root of 5 over 3. Now cosecant has to be the reciprocal, which is going to be 3 over the square root of 5. We should rationalize this because there's a radical in the bottom, so that's going to get us 3 square root of 5 over 5. All right, now cosine is going to be x over r, which is going to be 2 over 3. So that means secant has to be the reciprocal, which is 3 over 2. All right, tangent is going to be y over x, which is going to be the square root of 5 over 2. Cotangent is going to be 2 over the square root of 5. Now if I square root the top and the bottom, or multiply by the square root of 5 on the top and bottom, I get 2 square root of 5 over 5. And then those are my 6 trig ratios. All right. Now the last kind of question that you're going to see are some of the quadrant angle questions. One thing that you should know for these quadrant questions is where each angle is, right? I have 0, 90, 180, 270, and then 360 comes all the way back around where 0 is. If I have anything outside of this interval, you can either add or subtract 360 until you get something that's a little more familiar. All right, so cotangent is going to be at 0 degrees, right? So on the coordinate plane, 0 degrees is right over here. I can pick a point on 0 degrees and notice that it looks like it's somewhere around 1, 0. So I know x has to be 1, y has to be 0, r has to be the distance from the origin to that point, so that's just 1 unit. Cotangent, keep in mind, is going to be x over y, so this is going to be 1 over 0. Anything over 0 is undefined. All right. Now something like cosine of 90, keep in mind where 90 is on the coordinate plane. That's going to be up here. So again, I can pick a point at 90 degrees. I can say that this is 0, 1. So I get x, y. And then this is 1. Cosine is x over r. So 0 over 1, which is 0. All right. Tangent of 630, I don't know where that is on my coordinate plane, so you can subtract 360 to get a point that's a little bit easier to recognize. And you can see that this is the same as tangent of 270, and we should know that 270 is down here. Right, so I can say that that's a point 0, negative 1. Remember that tangent is y over x, so it's going to be negative 1 over 0, which is undefined. All right. Now sine of negative 270, again, you could know that negative goes in the reverse direction, but if you didn't want to deal with the negative, you would add 360, and we get sine of 90, which is up in this part of our plane, right? And that's going to be at the point 0, 1. All right, so I can say that this is an r value of 1, and sine is y over r, so 1 over 1, which is 1. All right, now cosine of negative 720, once again, I can add 360 on both sides. I'm sorry, not on both sides, inside, to get an angle that might be easier to work with. I get cosine of negative 360. Again, from here it should be clear where that angle is going to be, but if it's not, you would add 360 again. And then you get cosine of 0. All right, so cosine of 0, 0 degrees on your coordinate plane is going to be somewhere over here. And this point I can say is 1, 0. So x is 1, y is 0, our r value is going to be 1. That's just 1 unit away from the origin. So cosine has to be x over r, which is 1 over 1, which is 1. All right, and now secant of 180. 180 is on this side of the x-axis, so it's going to be negative 1, 0. Secant is r over x. My x value here is negative 1. My r is going to be 1. So it's going to be 1 over negative 1, which is negative 1. All right, all of these values that we got, you can verify using your calculator just to check that you're doing it correctly. But that's how you would do it, showing all of your work. And that covers all the kinds of questions that you're going to see on your test.